Hi, my name is Nate. This talk is called HTTP All the Things. Try that again. All right. So, hi, my name is Nate. Just a little bit about me. I used to be the lead developer of CakePHP, which is a framework that Mark talked about a little bit earlier today. So I was one of the, how many lead developers did you mention? 3? So anyway, I was one of those guys. I worked on another framework called Lithium, which I still work on. And I am also a member of the Angular UI team. How many people have heard of AngularJS? Sweet. What about Angular UI? All right, a few of you. Awesome. And finally, you can follow me on Twitter if you're into that sort of thing. So, a little bit of history of what working in HTTP with different APIs is entailed. Really quickly, let me see if I can get rid of this. Whatever. Sorry. Come on. F11. Yeah, I know if I go into full screen mode, I can't see my speaker notes. Such is life. So in 1998, that was the debut of both SOAP and XML RPC. It was a very bad year. Very good year if you like XML, but for everyone else, it was a very bad year. So interacting with APIs under the regime of XML kind of looked something like this. You had an XML header, which is very dark, and then you had some other more light-colored text, but there was a lot of angle brackets and just generally a lot of text that you don't want to have to mess with. Your alternative was a slightly smaller number of angle brackets and slightly less text, but still a lot of angle brackets and text. You can see where we're going with this. Now, the drawbacks to these approaches weren't actually the angle brackets and the text, but that everything happened over HTTP post. As a result of this, the details for what you're actually trying to access in this system that you're talking to, it's all encoded in the body, so it's not exposed as HTTP intended. Also, you're locked into using XML, and who wants to do that? There's no room for relationships or expressing, oh, there's other things that you can do in this system beyond call this method. And so you can't, there's no ability to discover other things about the system. You're just making method calls. So in 2000, a guy named Roy Fielding wrote a big, long dissertation on something called representational state transfer. In this dissertation, he laid out a few of the constraints that HTTP applications should conform to. So most of these are pretty straightforward. Client server, you have a client, usually a browser or an API consumer, that's talking to a server that's going to serve you some things. Pretty straightforward. It's stateless. HTTP itself, although it has cookies, there's nothing inherently stateful to the protocol. So if you call up the server and say, hey, server, how's it going? Server says, hi, how are you? My name is server. Call it up again. Server says, hey, how's it going? My name is server. How are you? So it doesn't remember anything about you. And that's really important for developing things at a very, very large scale. You have to remember this dissertation was being written about applications that are intended to run on a global network. And while we think, yeah, web scale and stuff, it's not something that we really ever stopped to consider that we're writing software that 20 years ago would have been totally unthinkable. So keeping these principles in mind is really important. It's cacheable, whatever. It's important, but I'm not going to talk about it during this talk. The most important things, though, are uniform interface. Opaque layering, you hit a URL, you don't really care the network architecture behind that. That's a really important innovation, whatever. And code on demand, basically downloading JavaScript. That's an optional constraint, by the way. So now, uniform interface, that's the really, really important one. Excuse me, and that's the one that everybody kind of fell down on. Even today, very, very few APIs implement this correctly. And there were 4 levels that basically defined how righteous you were in the religion of REST. The first level was you're just using HTTP. So SOAP and XML-RPC actually qualify for level 1. Or sorry, it's level 0. It's zero-based indexing on these levels. Secondly, the second level implies doing resource URLs. So each resource that you're going to interact with has a discrete URL, and a resource is just a thing. So host, or a task list, or anything that you're making accessible in your API should have its own URL. So, level 2 has to do with HTTP verbs. Basically, you use post for create, get for getting, patch or put for updating resources, and delete for deleting. I'm assuming everybody's familiar with that level of REST. Sweet. Finally, and again, this is the level that everybody kind of fell down on, hypermedia controls, which is why if you're a cool kid, you no longer say REST, but you say hypermedia, and I just pronounced that Hadios. I don't know, there's probably lots of different valid pronunciations. I'm not going to go there. So when we refer to a system that is actually REST compliant, because everybody's kind of hijacked what that term means, instead we just say hypermedia or Hadios. And so the first reason, as I said, is that REST kind of like doesn't really mean anything anymore. The second reason is that it emphasizes the parts about REST that are actually really, really important. So what is hypermedia? It basically breaks down to 2 things. One is content negotiation, so properly using content types, and state transfer, so representational state transfer. And we'll look at what those mean. First, we'll start with content negotiation. So this is content negotiation, right? Wrong. So that's not really, I mean, it's content, it's a content type in that it's a format. But this is a much better example. So RSS is kind of the canonical one. It designates a format, an application level format in addition to the serialization format. And that's indicated here. So, and this is generally the form to follow. So it's like application slash whatever part is relevant to the application and what the application is going to process, plus whatever the actual serialization format is. So here's what this example might look like with something like the Twitter API if they actually implemented this correctly, which they don't. So here we have these 2 parts broken out. Again, the application-specific stuff is in blue, and then the JSON stuff, you can't really tell, but it's in green. And you can actually use this to intelligently process this information. So you can strip off the plus JSON and say, okay, this is JSON, this is XML, or plain text, or whatever. This is something that I can deserialize. I can decode it from whatever the server is giving me and then hand it off to some application-level business logic. So for example, like a Twitter stream class that manages tweets can raise its hand and say, hey, I understand this. I know what to do. Give this to me, and I can decode it into something that you can use. So that's what real content negotiation is about. So the second part of that, again, is state traversal. And that basically involves state machines. So this is a very simple diagram of the state machine that has a lot of notation that we don't really even have to care about for this talk, because all state transfer is really about is the client asking what's next, which is a ¿qué es lo próximo? Maybe? I tried. So what's next means generally 2 things in the context of HTTP and specifically browser-based applications. It's like, where else can I get from here, and what's related? So the good news is that we actually already do this every day. In browsers, you have a bunch of tags in the header for things like style sheets, or rel equals next to indicate the next page in a sequence of pages, or getting an RSS feed that's associated with the page. So those are actually other resources that are represented in the state machine of our application that the browser can traverse to get to. We're only starting with one URL, but through the URL of our application, a user, in conjunction with a browser, can actually traverse through the entire rest of our application, only knowing the one entry point URL. And again, users, with the help of a browser, can load up a page and see a link or a form, fill it out, and traverse to the next state in your application. So your application isn't, again, a bunch of pages that are tied together. It's not even a bunch of controllers and actions. It's actually a state machine where you're traversing the state machine from one state to the next to do whatever it is you're trying to do. A really good example of this is the Atom protocol in a format. It actually is one of the few things that does HTTP correctly. So it does the methods correctly, it does error response codes correctly, all that stuff. But it's XML. Lots of words and brackets, and we don't want any part of that. Instead, we can have a similar type of structure in JSON. So I'm representing the same or similar data, or whatever data I want to, because it's JSON, but then I can have a special property, like $links, for example, where I can structure the data about the other things that are related to this particular resource. So it can identify itself with a key called self, and that has the href of whatever the canonical URL of this resource is, so I can refer back to it, or if somebody just hands me some JSON, I can say, oh, this has a self, so I can go back and reload it from its its canonical URL. It might have an owner, or in the case of a blog, an author. And you can go fetch information about the author. You can traverse through the application based on how the data in the application is related. So why is this important? Well, to answer that question, we are going to switch to something completely different. So AngularJS is a very popular JavaScript framework, and it's part of sort of this new wave of JavaScript frameworks that is delivering like a higher level of abstraction over existing tools. And I'm going to be talking about AngularJS, but there are a lot of different ways to do the things that we're going to be talking about here. Ember.js is a good example. Knockout.js. A lot of people use Backbone, but it's not really, Backbone's not bad, but it's not really at the same level of abstraction as these other things are. With Backbone, at least, you don't have jQuery soup. It's an organizing framework for jQuery soup, so you still have to touch jQuery, but not as much. So AngularJS, what are the basic benefits? And I had to go back and review this slide after Brian's talk because I want to tell a better story about AngularJS. So here's my story. AngularJS lets you operate at a higher level of abstraction than jQuery or simple DOM manipulation. It provides your applications with a simple and well-designed architecture, and it's fabulously easy to write tests for it. So we'll take a real quick look at some of the differences between AngularJS and, for example, just using jQuery to help illustrate some of why it's such a cool idea. So, and again, this is not to bash jQuery, because jQuery is obviously a great and effective tool. It's just jQuery is kind of down here in terms of abstraction, and AngularJS is up here. So the intent of the tool is very different. So event binding, it's really hard to see. Actually, it kind of doesn't matter because it's like you have your DOM elements, and then you have like a bunch of lines of code, and that basically just update a text box. So whenever I type in here, oh, there we are. So whenever I type in here, I want to update this guy. And this is the binding code. Oh, hey. So we'll just hang on to that for a minute. Yeah, so we've got our document ready, key down, okay, key down, get the value, and update the target element. Here's the equivalent example in AngularJS. You notice I'm not writing any JavaScript at all. So here, you've got a text box here. This is actually a live example. All right. Come back. Oh, there we go. All right. So again, jQuery. I'm not going through the color flipping thing again. So here's an example with just simple iteration. You're going through a loop. You have a bunch of elements, or you have a bunch of data points. You want to add an element for each one of those. So you can kind of see here, we're looping over each one of these words. And for each, we're going to grab this thing called greeting and append a list element, whatever. Right? Again, equivalent code in AngularJS. I'm writing a simple expression with the things that I want, and then I have a simple templating syntax to render those things. And one of the awesome things about Angular as opposed to other equivalent JavaScript frameworks is that all your HTML is actually live HTML. It uses the DOM as its templating language. And actually, I need to fix this, so. So here's a slightly more sophisticated or complicated example. It's kind of like a typical shopping cart, right? Like you have a bunch of items, you want to update prices and quantities, and present a total. So here's just really quickly what that looks like. So we've got some stuff, and stuff costs money. Every time we add a new thing, we get a new line item. It does the subtotal for each line and a grand total at the bottom. And in Angular, the HTML listing for that code looks like this. So I've got this new thing called a controller, and that's a JavaScript function. And then that JavaScript function is giving me a list of things called items. And I'm going to iterate over each one of those, and for each one, I'm going to generate the 3 text boxes that you saw, and I'm going to do a little expression down here to multiply the quantity times the price, and that little pipe symbol, that's Angular ease for doing a filter. So I'm going to filter this data as with the currency filter, and it's going to output it, and we're all going to be happy. And then down here, for printing out the grand total, we're going to call this function called total, also output it as a currency. And here is what, can you all see that? Is that readable in the back? Okay, great. So this is our checkout controller. It's just a simple JavaScript function. I've got this thing called scope that Angular's dependency injection system automatically is passing to this function. And I'm just going to assign some things on it. Scope just represents the area that that controller manages, so anything I want to expose to the template goes on scope. So scope is going to initialize items, and then it's got this total function that reruns every time anything gets updated. So we can use it to watch and append new items, and then finally calculate the grand total. So pretty straightforward. So What about organization in jQuery? Angular's, but again, it's not really jQuery's job, so it's kind of an unfair jab. Now, what about testability in AngularJS? By default, AngularJS encourages or recommends the Jasmine test suite. So if we were to test our JavaScript controller, this is what it would look like. So we're testing that it initializes a default item, and then this test tests that the total is calculating things correctly. And it's great because all of the business logic is happening completely isolated away from the DOM. So it's really, really easy to test any complex logic that you're doing without having to fire up, Phantom.js or, fire up your browser and click through it manually. And as for jQuery, well, we're just not even going to go there. So what about dealing with HTTP resources in AngularJS? By default, there is a library called ng-resource that's accessed this way. That is provided by the AngularJS core team, and it's wrong. Here we're going to look at why it's wrong. So here's how you use it. You define a resource, a thing that you want to use. Let's say it's called task, and then you give it a URL template, and then you tell it how to map the properties inside of each of your task objects to the URL. So I'm saying my task objects have an ID, and that ID should go in the URL in this :ID place. Simple routing stuff, right? So then I can create a new task and save it, and it's going to do a post request with my data. And I can also retrieve that data, and it's going to do a get on task/5. And if I want to do a query, I can pass it some parameters, and it'll serialize that into a query string, run my query, and give me back my array of objects that it matched. This is bad. This is bad news. No me gusta. The shenanigans. Jeff made up that word today. Shenaniganos. It's a new Spanish word. So, why is this bad? Well, I mean, it's basically encouraging tight coupling between your client and your server, and you're actually encouraging bad API design. So it's very, very much not in the spirit of how HTTP applications are meant to be designed. Clients should never have to generate URLs client-side. Now, the one caveat for that is, yes, I know that IETF has an RFC about URL templates, but even those are the client is being informed by the server what the URL should be, what the structure of the URL should be. I still don't think it's a good idea because, again, it encourages bad design. We'll look at why in a minute. So one thing you can do is to mitigate a lot of query string parameters, for example, is designing your API around intent. Intent is the idea of anticipating what a user or client of your API is going to want to do. So what does this mean? Can anybody infer from the parameters like what this is doing? Sorry? Well, we're querying, yeah, I don't have a HTTP method, but pretend it's a get, right? Would you care to revise your answer? Getting all tasks. Right, so it's getting all tasks constrained by the ones that are not completed, and that date is next week. So all the non-complete tasks that are due next week. But what does that really mean? Like this thing that I'm typing isn't actually giving me any information about what that data means. It doesn't have any meaning. Whereas this, task/current, these are my current tasks. These are the tasks that I care about currently. It's very terse, it's very clear, it communicates. I don't have to care about a bunch of parameters to pass to it, right? And So I can change underlying pieces of infrastructure and details about how this is implemented without breaking the interface. Because what I see most people doing is they'll expose their API as basically an HTTP way to do CRUD operations against the database. It's bad API design. You're not doing your API clients any favors. An application is supposed to do intelligent things with data, not just give you, a bulldozer to shovel it back and forth. So like the scaffolding, for example, that a lot of frameworks give you, that you just kind of go with. That's actually, you're not doing anybody any favors. Also, it's, as I said, it's very brittle. Like you change one parameter and the whole thing breaks, rather than being able to optimize and be intelligent about it. So what's actually bad about client-side URL templates? Maybe instead of tasks, we can take a look at a slightly different example. So what about posts? Again, same kind of structure. The data that we're looking at with posts is, so we got a title and a slug, and there's probably a body information, some other things in there. What if we change the URL structure? Well, that kind of breaks our previous model. We have to go back and tell the client, instead of binding to IDs, we're actually binding to this thing called slug. So again, it's basic type coupling like you would have between classes, but it's between your client and your server. So what's the alternative? What can we do about this? Well, as with any good open source developer, you can write a project. Why? Well, because everyone else is doing it wrong. There are other HTTP libraries other than the standard one for AngularJS that do different things, and they all have different strengths and weaknesses, and they're all great, but none of them actually use HTTP to its fullest, particularly with respect to links and being able to link resources and hop from one to the next to the next. So, what does this thing do? Well, let's see. I need my story notes again. So this is basically what the code looks like when you're defining models in Angular Model. So it's just a simple way to attach business logic and behavior to HTTP resources that you're exposing through an API. And it can grab these on the client side, manipulate them in the browser, and save them back using HTTP to its fullest potential. So it's leveraging HTTP, and it doesn't generate any URLs. All URLs come from the server. But you're writing code like this, so how does it actually know where tasks are coming from? You still have to configure it with an API URL. It's not going to figure that out for you. But you don't have to do API URL / tasks. It's just you're giving it the one single endpoint to the API. So then where does it get the specific URL for tasks? Well, we've got three options. So by default, it will take whatever API endpoint you give it / whatever the name of the resource is. That's automatic. It's good for development. It's not really what you want in production. So two other options. One, generally you're going to have an HTML template. A lot of times it's going to be generated through PHP. So we can actually steal the same technique that Adam is using. So it's a little bit hard to see. But we can actually just use the server to generate the URL and embed it directly in the template. And Angular Model will pick that up. Or you can use another feature of HTTP, which is having the system tell you about itself. So this content type, I literally just made that up. You get to make up your own too. That's the beauty of it. So what does this tell me? Well, when I get / or the root of my API with this particular content type, I know it's JSON and the vnd.resource def that tells me something about the structure. Well, the structure is going to be a bunch of names of resources with their URLs. So I can go take those and find out where to get other things after I've paired them up with my business logic. So that's great. We've got some tasks and users. Well, what if I want to know what's in those tasks? What's the structure of that data? Well, we can just use the HTTP options method and make up another content type. But just so you understand, we're not making up content types for content type's sake. What we're doing is making up a name of a thing and assigning some behavior to it. So you can write a class that understands the structure of the data that this thing returns, and you can give it to someone else. And maybe they can make their changes and update a standard so that hopefully, eventually, everybody can kind of converge on a few schema types or abstract media types that make sense for a broad category of things. But you could have content types for different industries. Maybe if you're crunching airline data or information about cars, sales, Mercado Libre, all that stuff. All those different business things can all have their own content types, and people can develop common tools around how to process that information. So here is more HTTP goodies that you don't need to reinvent in your own applications. HTTP range is kind of a cool one because, as with a lot of things in HTTP, it's totally overlooked. Nobody's really using it for anything interesting. Usually, almost always where you'll see it is when you're serving videos or large files. You have this thing, range bytes equals, some byte offset, so you're getting 100 to a very large number of bytes, right? Now, this thing right here, that doesn't have to say bytes. That can say something totally different, and you can actually tell the client what things it can ask for ranges of. So let's say head, which is just like a get, but only returning the headers. I'm going to get some information about posts. I'm just going to say, hey, I accept ranges of posts. Well, that's cool. Maybe I can get some post offsets, and boom, pagination. Yes, question in the back.
It's actually not a question. You said nobody was using it for anything interesting.
Well, then I've done a lot of research, so the question, or the statement rather, was nobody's using it for anything interesting.
That you know of. I know. I was just going to tell you that we're actually using it to paginate REST, our REST API. So that's awesome. We should.
Bam! Great minds think alike, right? High five. That's great. Yeah. So it's totally useful. There are all these goodies in HTTP that nobody or very few people, thank you, awesome guy, are using.
Thank you too, Random Citizen.
Sorry?
Thank you too.
Like YouTube?
No, thank you too, Random Citizen. You know the line from Megamind? And I love you too, Random Citizen.
I love you too, man. Oh yeah.
Okay, there you go.
Awesome. HTTP auth, obviously everybody's heard of it. It's great. One of the great things about HTTP basic auth is that it works from pretty much anywhere. Remember, always use protection, by which I mean SSL. But again, if somebody wants to test your API over curl or whatever, you just type in the name and password on the command line. It's great. Caching. Some cache headers are created more equal than others, but the upshot is that you can use the combined all of the cache headers that HTTP allows and implement basically any caching strategy you could ever want. So what about PHP? There's been like one line of PHP code in this entire talk. So I have another library. It's on my GitHub account. It's called Li3 Resources. So I mentioned at the beginning of the talk, I work on a framework called Lithium, and this is a plugin for it. But the concepts that are used in this are not special. Like you could implement them anywhere. Now this particular library is experimental. We'll get into that in a second. Here's basically what it does. So in addition to exposing resources as for the basic prod operations via HTTP, Instead of controllers, you write resources, and it automatically maps your HTTP verb to your resource method. So that's great. It also gives you parameter mapping in conjunction with routing, so that in addition to having your routes and that returning a database object, you can also go the other way and take a database object and turn it into a route, or turn it into a URL. It also will automatically generate links for all of the model objects in your model relationships. So when you're outputting a post, for example, it will generate that $links object, and it'll have self, and here's my author, and here's where to get my comments, and everything else about that object, just based on your model relationships. It also exposes schema information with the options or the options method. So in my schema definition, I can add a description key. So we define, in most of my work, we use MongoDB. So we define the schema at the application level. So when we're defining the schema, we can say, hey, here's the description of what this field means. And not only is that description useful, but that is a signal to another part of, sorry? Oh. Yeah, my email client does this thing where it launches automatically. It turns out to be really annoying. Anyway, yeah. So I have these classes that will take a look at the schema information and say, for all of the ones with descriptions, we want to make those public. So when you do an options request, it'll give you back all of the fields that those objects are going to have, along with the description of what each one means. So that, in addition to making the API introspectable, it's also self-documented. So let's see what else. Oh yes, and we have these proxy objects. So as I said earlier, you don't want to just take database objects and dump them out to the client as JSON. You're not really adding any value. So we've made these proxy objects that allow you to take database objects and process them progressively. So all of those things, the schemas, the links, all that stuff is done with proxy objects. And you can write your own. For example, we have one that will take a MongoDB ID, since that has timestamp information embedded, and we'll extract that and make it a created field. So all our database objects, when they're exposed in the API, automatically have a created timestamp attached to them, and we don't have to store anything extra for that. So coming soon, range pagination. Search is one of those things where usually, you'll want to search on a bunch of different things, like search the title and search the body. Usually you just want to search stuff, and a really good convention for that a lot of people use is just Q equals whatever you're searching for. And so we're going to implement that, where anytime you're searching over interfaces or over resources, we'll just say, if this text appears in any field that contains text, or like a string that's a title or body or whatever, it's configurable, we'll use those for search. So you don't have to really think about that. And also coming soon are unit tests. Thanks.